Assalamualaikum and hi, we will be presenting Calculus 1, Topic 3, Application of Differentiation. Our group name is cohorted from CS110 and we are from different group 3B, 3C, 3E. Our group member consists of 4 members, Aini, najwa, binti, adrus, Siti, Nuran-nisa, binti, Nadzri, Siti, Zubaidah, binti, Zulkefly, and Fatin, Nazira, binti, Zakian. We have decided to choose analysis of function 2 for our group project.
So I'm going to start with the introduction of the topic. What is differentiation? Differentiation in mathematics, especially in Calculus 1, it is a process of finding the derivative or rate of a change of a function. So what is analysis of function 2? It consists of critical points, finding the interval whether it is increased or decreased, and the next step is determine the extremum point and see whether the graph interval concave upward or downward, and find the inflection point, and then the last step is we sketch the graph. So let's look for the first question.
Okay, for the question A, given a function fx equals to 3x minus 6 over x plus 2, and find the x-intercept and y-intercepts. The first step is, when we want to find x-intercept, y is equal to 0. So fx is y equal to 0 equals to 3x over 6, 3x minus 6 and over x plus 2. So the denominator of this one is x plus 2, which is we multiply by 0 equals to 0. So 0 equals to 3x minus 6, and negative 3x equals to negative 6, and x we get 2, the answer. Okay, this is for x-intercept. The second step is we want to find y-intercept, which is x equal to 0. So we replace x with 0. So y equals to 3 in the bracket 0 minus 6 over 0 plus 2. So 2y equals to negative 6 and y equals to negative 3. So we get the answer, x-intercept is equal to 2 and y-intercept is equal to negative 3.
Hi, Assalamualaikum. My name is Siti Nuran-nisa binti Nadzri, and I will explain about question 2. How to find the vertical asymptote and horizontal asymptote. To find vertical asymptote, we need to let x plus 2 equal to 0. So the answer is x equal to negative 2. To find horizontal asymptote, we need to lim x positive infinity. So we need to use formula power rule to solve this, and the answer is y equal to 3.
The third question is find the intervals where f is increasing or decreasing. So the first step is we have to find the derivative f prime x. This is the function and we have to use the quotient rule because it is a fraction. As we know that the numerator is u and the denominator is v. And we just have to find the quotient rule and substitute this into the formula. So when we substitute it, we will get this. Okay, I'll proceed. U is 3x minus 6 and this is 1 over in bracket x plus 2 squared. So we just have to solve it. And the final answer is 12x plus 2 squared. Okay, so for the step 2, we have to find the critical values. The denominator must equal to 0. So the denominator is x plus 2 equals to 0, and x, we move the 2 to the right side, it will become negative 2. Okay. So the critical line, step 3, alright? Okay. Because the critical value is negative 2, so we put here negative 2. And there are two intervals only. So here, the first interval, and this is the second interval. Alright, so the last step is we have to make an analysis. So, because there is no any number except for negative 2, and this is the negative side and this is the positive side, so we put here interval as negative infinite to negative 2, and this negative 2 until positive infinite. Okay, so the test value, you can just put any number that before and after negative 2. So I put here negative 3 and this as 0. So we substitute this into the sign, into the function. Then if the final answer is positive, we put here positive sign. Then it is increasing.
Assalamualaikum and hi, my name is Siti Zubaidah from class 3E. In this video, I'm going to explain question 4. The question asks us to find the interval where f is concave up or concave down, hence determine the inflection point. So in the first step, we need to find the second derivative of function f by using the second derivative test, which is fx equal to 12 per with x plus 2 with the power of negative 2. Then for the second derivative of f equal to negative 2 times with x plus 2 with the power of negative 3 equal to negative 24 in bracket x plus 2 with the power of negative 3. And then we got the answer, which is negative 24 per with x plus 2 with the power of 3. Next, the second step is we need to find the inflection values. Let the denominator of derivative f equal to 0. So we got x equal to negative 2. Then move on to the third step, which is the inflection points. And when x is equal to negative 2, we got the answer that the inflection point is undefined because it is equal to 0. So the inflection point does not exist. Finally, the last step is where we need to do the derivative table. Here we have two intervals based on the inflection line here, which is the first is negative infinity to negative 2. Meanwhile, for the second interval, we have negative 2 to infinity. For the first interval, I'm using negative 5 as the test value, and we got positive, which means it is concave up for the conclusion. Lastly, I'm using 5 for the second interval, and we got a negative equal to concave down as the conclusion.
The last question is sketch the graph of using the above information. So we already know that have a line at x equal to negative 2 and y equal to 3. So we need to sketch that line. After that, we need to sketch the line between interval negative infinity till negative 2 is increasing and concave up. Beside that, negative 2 till positive infinity is increasing and concave down. Based on the graph, we notice that they have two intercepts, which is y-intercept at negative 3 and x-intercept is 2.
Overall, from this topic, we can conclude that with integration and differentiation as mathematical technique, we have been able to reach the solution of the different methods used, such as find the x-intercept and y-intercept, find vertical and horizontal asymptote, and also sketching the graph. Each of the method brings a simple and clear way, thus can be used for practical data.
For the reference, we refer notes from our lecture, Chapter 3 Application of Derivative, 3.3 Analysis of Function 2. We have finished our presentation. That's all from us. Thank you for watching.